This is called the myCobot 280. It's a small robotic arm with a payload capacity of about 250 grams. We'll start off by 3D printing one of those fancy pasta spoons. We're gonna add some screws so we could attach this to the end effector of the robot. I made this metal frame in order to hold that robot horizontally on top of a pot of boiling water. We can mount some screws to attach the robot arm with. It seems to be able to stir the water without much of a problem. In addition to stirring, I hate having to wait for the water to boil every time I make pasta. It's so annoying. To combat that, I created this. It's like a paintball hopper, but instead of being filled with paintballs, it's filled with pasta. We have this trap door here at the bottom, and that door is gonna open as soon as the water's boiling. We'll know the water's boiling because we'll use a humidity sensor to figure out when the humidity is really high. I designed the trap door to let out the pasta with a simple linkage. Then I 3D printed all the parts. I also created a hinge to attach the door and added a micro servo to power the movement. Now let's fill this thing up with pasta and see if the robotic arm and the pasta spiller can work together simultaneously. Seeing these systems working together was really rewarding. After about 10 minutes of this, I took the pasta out. Bon appetit. So it can cook pasta. Big whoop. Now with dinner finished, it's time for dessert. I want to see if this robot can help me make muffins. I took apart the gripper that came with this robot in order to create something new. Here's the little motor from that gripper. I attached it to this special batter dispenser that I made. At the base is a hole. That hole is being covered by a mechanical door that will open and close and allow the batter to come out into the cups. I mixed the batter and readied the muffin tray for dispensing. You can see how that hole inside is going to open and close to let the batter out. With the batter finished, it was time to pour it into the batter dispenser for a first test. This first test did not work out as planned. This stuff is just way too thick. It can hardly come out of that hole. I'm gonna have to add some water and try this again. The mixture is starting to move out of the hole, but instead of making the hole bigger, I just opted for changing the formula. I added some more water and oil and tried again. Okay, that's what I like to see. Consistent flow. And in addition to consistent flow, it seems like that arm moving back and forth is cutting off the flow very well. Seems like we're back in business. Speaking of business, Elephant Robotics is the company that sent me that robotic arm in order to make a review. And they're probably not gonna like the fact that I took apart this gripper in order to take that motor out. But the way I see it, what are they gonna do about it? What are they gonna do? This software allows you to move the robotic arm around yourself with all the servos off, and it can visualize the position of the robot on screen. This software is called RViz, and it's included with ROS 2. You can use this coordinate information to better design your software to move the robot where it needs to go. I find this software is best for understanding which angle is which, and what those angle measurements often are, so that you could use the next software that I'm going to show you for waypoints. The Raspberry Pi is reading the angles from the robot. So as I click on these buttons, it's actually going to move the joints, and we're going to position the robot in the way that we want. We can program this block, that yellow block, to be the angles that we have set here in the joint control. So we're going to click on Read Angles, and that's automatically going to set the position. and then we're gonna throw a sleep in between. And what we could do is copy and paste that first set angle and change it to be whatever we want. And this is how we get the robot to move from one position to another. I find that myBlockly is the easiest way to start programming the myCobot 280. I hope to do some more experimenting with this robot, especially in the kitchen. What do you think are some other ways that I can mix the water, or mix the pasta, or maybe even create or mix some other type of food product? Let me know what you think in the comments. For this project, I was able to connect my Raspberry Pi to my laptop, and I was able to use my regular mouse and keyboard of my laptop to control the Raspberry Pi. How is that possible? Don't you usually need an external monitor? Well, not anymore. The device I used is this. This is the Cytrance Kiwi Pro, and it's a very simple device. One of the cables goes into your video connector, and then another one goes into USB, and then on the other side, this plugs into the computer that you want to use. Because this is a Pro version, it also has this connector here at the top, and you can plug in GPIO pins, so you don't even have to plug them into your Pi. I gotta say, I really like this device. I thought it was very helpful and very useful on this project. I want to give them a thank you for sending this to me for free. I can't wait to keep using it.